All right, let's take a look at solving coding challenge number 3 with the Tidyverse. Now, if you watch the next video in this playlist, or the previous video if I haven't fixed the playlist yet, you will witness me go through the struggle that was involved in making this all work. But in this video, it's going to be a stripped down version where we just see the bare essence, and I'll explain weird little things as we go and refer to the struggle that happened in that previous video. So let's go ahead and start by clearing things out so that we make sure everything works from scratch. We're going to load in the Tidyverse, which I already have, so it's not printing out like it normally would, but rest assured it's in there. Now I'm loading in my data, but I'm then piping it into a little bit of extra functionality to make a couple tweaks. And these tweaks are going to make it a little bit easier for our functionality lower down to work. So I load in pop.csv, and then I mutate the column that would be county A FIPS. By default is loading in as an integer, and here I'm just forcing it to be an integer. There are easier ways to do this, or maybe tidier ways to do this. This is the easy way, right? But there are sort of prettier ways to do this by building it into this call to read underscore CSV. But don't worry about that. So we're creating pop with read underscore CSV, where we're pulling in that comma separated value of population information. Then we're taking that data frame and we're changing two columns to force them to be numbers rather than text. The short version of the big problem when I ran through this an hour ago is that in one of our data sets, a state code for like Alabama 001. In one of the data sets, it would show up as 001, and the other one, it showed up as 001 space. A really subtle, hard to pick up error. So here, 001 space or 001, it all just turns to 1. And that's going to solve some problems for us. So if you're getting some weird results, then this might help you to do this. And after this, I'm going to go back and redo the base R version, because that's probably what most of you guys are going to be doing at this point. So same thing for flows. We import the data, we convert the codes for state and county to be numbers instead of text. And then we've got a bunch of joins. And actually, I'm going to get rid of these. But if you watch the other video, the short version is an inner join. We take two data sets, and where there's overlap, we keep that and we get rid of the rest. A full join, we keep everything, and that's going to lead to some weird things. We're going to have some empty numbers here. We're going to have some empty numbers here. And that's going to give us some weird looking results. Normally, I'd advise don't throw away data, but in this case, if it's not in both data sets, we kind of don't really want it, right? So full join, not the right tool for this particular job. And again, our goal here is to get better with the tools. We're not trying to get the right answer to understanding county flows. So if we mess stuff up in terms of, getting exactly the right stuff, we're fine, right? I don't really care about getting stuff exactly right this week. So we don't need to full join. Left and right join. Left join, we keep everything in pop, and then anything that isn't overlapping in flows gets thrown out. With a right join, it's the reverse. We throw away anything that isn't in flows, we throw away anything that isn't in pop and keep everything that's in flows. But we're not going to do that. We're just going to do the inner join. Let's tidy this up a little bit. So let's go ahead, load in pop. Notice when we load this in, it is recognizing that we have comma separated values, and it's specifying as character, as text data, the state A FIPS, county A FIPS, state A name, county A name. Right? The names definitely have to be text. These FIPS codes, they should be text, but we're going to treat them as numbers. We could do a little bit extra, finagling to make things make a little bit more sense, but I think we've got stuff so it works, so we're not going to add unnecessary complexity right now. And then double, this is a decimal number. Population, births, and deaths, those should be integers, but whatever, right? It's a number, fine. Load and flows, we should get similar stuff, except now we've got state B, county B, so we've got more text. And then the rest, the error margin, the number of people moving, these are all numbers. Good. Now, really the most important part of this task is joining these two things together. So all that we did with just this one line, inner join, stuck it all together, threw out anything that wasn't in both data sets. If we click this little button, or if we use the view function with a capital V, let's view df, and it looks good. We've got codes, we've got names, we've got data on population. Very importantly, we have data on population, and we also have, actual data from the county flows data set. If you were seeing a bunch of NAs here, a bunch of not available empty values, that would imply that something weird was going on. And I talk about that a little bit more in the next video, but the very short version is when it's combining these two data sets, it's looking at the column names, the names of each variable, and it looks for where there's some overlap. And there's overlap with state AFIPS, county AFIPS, state A name, county A name, right? These values, these variables had the same name, and so R thinks, ooh, those must be the same sorts of data, and it tries to match them up with state 1, county 1, Alabama, Autauga County in both data sets, and when it sees those, it takes a chunk of data and it latches it on to the rest, right? And it's going to make extra rows to match up with all this when necessary. So this looks good. If we sort by any of the values, we can scroll way down to the bottom, and that's where we're going to find any NAs. And in this case, we don't have any NAs. But what I can show you, without saving a value, let's do a full join, and let's view the results. So full join on pop and flows. We're going to pipe that into view. And what have we got? Let's sort by something, scroll way down, and we got a whole bunch of NAs, in this case, population, births, and deaths. So it's looking at Doña Ana County in New Mexico, and it's saying we don't see the population data. Now, if we look at, can we get that? No. If we sift through here, we will find that the formatting came in a little bit differently on one than the other, which is really annoying. And that's why we got a whole unit later in the semester about working with text. We're not going to worry about that right now. Notice that we've got these values. So the county flow data just didn't match up with population data. Let's search on something from that flow data, scroll way down till we find some NAs and see what went wrong. So here we've got all this flow data is fine, and then one row at the bottom with an NA from the Chugach census area in Alaska, a place with 7,000 people. I'm curious, where is Chugach? I was looking at some of the counties that were showing up in the weird results, and basically there were rural counties in Texas. Chugach, we got some coast here, looks like they got some fishing industry, census area located, blah, 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 has no borough seat. It was split from the Valdez-Cordova census area, which was one of the things that showed up in the other one. Okay, in the neighborhood of Anchorage. Cool. Back to R. So, we're doing the inner join because it's going to make our life easier, and it seems to have worked. So, important thing number one, take two data frames, join them. When you're doing work in R, very often you want to know something like, I have some data from the Census Bureau and I have some data from the stock market, and I want to know how one thing affects the other. You're going to have to take those different sources of data and mash them together into one thing that you can work with, and that's what we've done here on line 10. The next line, we're doing the other important thing, which is creating new variables out of that data. So here, we're taking population from the pop data and A to B flow from the flow data. We're not going to be able to do that until we join them together. Now that we've joined them, we can figure out what is the flow as a percentage of population. It would be nice if population was already in the county flow data, but it wasn't. So we've solved that, and now we've got a way to figure out, basically we've got a way to figure out where are people moving out of the most. Obviously, people are going to move the most in numerical terms out of the biggest counties, right? A lot of people are going to be moving out of New York City just because there's a lot of people in New York City. But does that really mean a lot of people are moving out of New York City compared to anywhere else? Well, as a percentage, we get a better answer to that. So what this is doing is it's taking for A to B, right? Anyone moving from county A to county B, it's figuring out as a percentage of county A's population, how big is that? Ditto for in percentage. Gross flows is just the two combined. You can also look at net percentage. Doesn't really matter which of these four possibilities you look at. I've just done 3, and I'm going to leave it at 3. Whatever, I can do that. Let's do net percentage equals, and let me get the name here, B to A net flow divided by population 2020 and a comma. Run that, no errors, good. Whoops, I've got to do that with something. No errors, but, oh wait, was this fine? All right, whatever. I don't know what error was giving me there, but seems all right. Let's make sure DF hasn't been messed up. That's good. Cool. So we've taken our data frame, and the change we've made to it, oops, actually, this will make it a little easier for you guys to see. The change we've made to our data frame is that it is itself, but with these mutations. These mutations are adding new columns. So if we view, DF, which we've got over here, we should be able to scroll over to the right, and we've got these percentage values. And these look like they're on the right order of magnitude, so that's good. Notice also we've got a little bit of math we can check here. So the second row, or out percentage, is 0, or in percentage is the same as the net and the total. So higher net percentage basically means more people are moving in than are moving out. Because if nobody's moving out, the net is equal to the in. All right, so that helps us to interpret. So if we want to know where is the least popular place, we can look at the biggest negative net percentage. And the biggest shift is people moving out of Loving County. Out of Loving County? Yeah. So, out of Loving County into Gaines County. Loving County is near Corpus Christi, but it's not Corpus Christi itself. So it's basically there's nothing there. Gaines County, I'm curious where that is, but let's see, A to B flow. So 21 people moved from Gaines County from Loving County to Gaines County. Oops, let's see where Gaines County is. Okay, that is interesting. So Loving's County is way down here, or wait, no, was it over here? Okay, it's not as far as I thought it was. I got that wrong. There are some counties that were in the data set, really small populations. Loving County is right over here. So West Texas, desert. But basically 21 people moved from here to here, or the other direction. They moved between the two. So it's, I don't know, maybe a big family, maybe a business moved and people moved with it. But I'm getting caught in the details. So overall, right, we've got a way to look, where are we seeing these big shifts? Big shift in the other direction, 20% going into Norton City County in Virginia. Population is only 3,600. So back to here. We've calculated these percentages and we've added them into our data frame. Now what we want to do is we want to get the average of those by county. And we have to specify by state and county because some county names are repeated in different places. So for example, if we go, let's go pop $ county a name, and let's plug this into table. Ooh, look at that. It gives us a little preview here. Oh, no, that's an example from the documentation. We don't have Afghanistan in our data set. Run that into table. We're going to get some issues because it's only going to print 1,000 things, but we can see, for example, there are 12 states with Lee County. I'll bet I know what part of the country they're in. We got 11 Lawrence counties. We got a couple Lane counties. So Lafayette County. That's interesting that there's 5 of those. Kings County, we got 2, I believe, 1 in New York, 1 in California. We also have a King County. That could be annoying. Most counties only exist in one place, but we have enough that exist in multiple places that we need to specify state and county. So we're taking our data frame and we're grouping it by state and county so that we're getting each individual Lincoln County. We're not averaging across all 23. If we did that, Lincoln County, actually, let's see. If we go DF filter gives us specific rows. We're going to look for where state A FIPS, or sorry, state A, county A name double equals Lincoln County. We got a bunch in Arkansas. Let's go ahead and pull the state A name. And let's see what unique states we have in that list. So there are Lincoln counties in Alaska, Colorado, Georgia, Idaho, Kansas. Let's look at from POP. There we go. And let's go ahead and view that because, hey, I'm curious. We're here. Let's take a look. So across these, we'll sort by population. We've got North Carolina, a Lincoln County with 87,000, and in Kansas, a Lincoln County with 2,900. Births and deaths range from 4 to 234, again, between those two counties. So if we were to average across Lincoln County without specifying the state, we're going to get some weird looking results. And that's going to be inaccurate. Right? It's going to lead us to a mistaken conclusion. Unless what we're investigating is, do people really like places called Lincoln County? So we group by that so that when we do summarize, it's going to look at things in the right way. It's going to look at the right groups of data. So it will get the mean population, which should be just a bunch of, the same number. I don't really need a mean population. Actually, I guess I could put that in the grouping category, and then I don't need to do this. So I group by these things. In this case, I'm adding population, not because I want to group by that. And you got to be careful if you were looking at multiple years, you definitely wouldn't want to do that. But in this case, it's just going to keep that column for me to make my results a little bit more readable. Just to give, I want to see that data in there. I don't necessarily need to keep births and deaths. Maybe I do, maybe I don't. Let's go ahead and put them in. We can. Well, actually, no, I got a better idea. I'm going to just do state A name and county A name, and then afterwards, and do summary stats, and let's go ahead and do a full join with pop. All right, so we can go back to that after. So we're going to group by county, by unique county. We'll deal with the population in that code I just wrote. And then for each of these things, we're calculating the mean in percentage and I am removing any missing values when I'm calculating that mean. Because if I try to average 1 and a blank space, it gives me back a blank space. If I average 1 and that's it, it gives me back 1. Or if I average 1, 2 blank space, it gives me back blank space. Unless I throw away the blank space, then it'll give me 1.5, which is what I'm actually looking for in that case. So I get the mean in, out, total, median in, out, total, min, in, out, total, max, and standard deviation. And I could also do net. Let's go ahead and do that. So change mean, let's change total to net. SD to, out to net. Oops. Is that right? No. Out. Why am I confusing myself? Oh, I know why. These other ones I copied total, that one I copied out. All right, so I want to change tot to net. That's better. Ditto for min, for median, and for mean I've already done that. All right. So I got a lot of things here, but since they're all the same format, it's easy to copy a line, paste it below, and then just search and replace all that stuff. The easy way to do that is if you do Control F. I've got Vim key bindings. I'll explain that in class, but you can just search and replace for each of these, and it makes it easier to copy your logic. But with this summarize, when we run that through, we get a bunch of stuff. Has grouped output by state A name. Let's make sure that looks all right. Summary stats. Okay, so we got 3,140. We've lost 3 counties. That's fine, but we've got about as many counties in our summary as we had in population. Let's go ahead and just join that with pop and view the results. And if we like it, then we will add that back in. So we've got state A name, county A name. We've got all these values we've calculated. Let's see. If we got one with a highest min, this is Kennedy County. This one's by Corpus Christi. Kennedy County has the highest minimum in percentage, but its population is only 346. So a few people move and it looks really big. They're only in the data set as a pair of counties where some people move from one to the other. Most other counties have other counties, so some people moved here, but nobody moved in from here. Their minimum value is going to be 0 because of that. Don't worry if that doesn't fit into your head, but you'll be fine. So we've got our population, births and deaths. We've got the stuff we calculated. One little tiny thing is I'm going to reverse the order here. So I'm going to say summary stats is going to be pop. Actually, I'm not even going to pipe it. I'm just going to full join pop and summary stats. And then I can write with, let's use Tidyverse, write _CSV. And now I can go into my files and make sure that I got something. And it's hard to read here, so let's go ahead and view the thing that I actually saved. State codes, state and county names, population, births and deaths, and then all these figures we just calculated. A little bit more readable doing it in this order rather than the way I did before, where summary stats joined to pop with population on the end. So write _CSV, we're taking this data frame that we just created, and we are writing it into a file called summary.csv, which is what we've got here. Now in practice, what you would do with something like this, well, this is 3,000 rows, so slightly different. What you might do with something like this, if you weren't calculating for 3,000 things, if you were calculating for 10 things, you might put it into a CSV, open that up in a spreadsheet program, format it nicely, and then copy paste that table into the report you're writing. But in any case, we have gotten through this. So let me do the very quick recap. We clear everything out. We load in the Tidyverse, which is a collection of libraries that make life easier for us, assuming our data is going to behave nicely, which in this case it didn't. But we load in the data. We do a few little tweaks just to get around some problems that I faced in that video that comes up after this. We join the data, right? So this is one of our key tasks. Then we add these new variables into our data, the other key task, and then we calculate those summary stats by county. And really these 3 lines is sort of where most of the action is visible. We take our data frame that we just modified, we group by the geographical area that we care about, which is each unique county. Not counting Lincoln County once, but counting it as 23 different Lincoln counties because it's in 23 different states. I shouldn't say it, they are in 23 different states. And then summarize, where we create a variable in a new data frame with some name, in this case mean in, to describe the mean in percentage for any particular county, which we calculate with some function. So the functions we're using are mean, median, min, max, and standard deviation. And we've got all these NARMs equals true to throw away any missing data so that we don't get back NA values for any of these. Just to show you how that could mess things up, let's go ahead and replace all these T's with F's. And do it again. And let's look at summary stats. And when we scroll over, oh, look, some of these are working nicely. That is reassuring. But we do have some NAs for Chugach and Copper River census area in Alaska. Notice when we did the NAs, our summary stats was missing a little bit compared to POP. We dropped 3. Those 2 census areas in Alaska plus Doña Ana County in New Mexico. Poor Doña Ana County, the only problem there is that Enye. Just a little accent over the N, and R just tripped over itself. Like I said, today the goal is not to solve that problem. We'll solve that in the future. All right, so we got it. We did it in the Tidyverse way. If you got questions, let me know, but a lot of this stuff is just going to feel better as you go through it and sort of get more fluent. If you are doing this in Replit, Tidyverse, there is a way to make it work, but it's going to take, basically you're going to want to pay extra money to have them give you more computation power so that it works in a reasonable amount of time, because we're dealing with hundreds of thousands of observations here, which is fine on your own computer. But on a free computer where someone's giving you a teeny tiny bit of RAM and a teeny tiny bit of CPU, it takes a long time. If you're in base R, it's going to be a little bit faster on Replit. So next video I'm going to record is going to be a rehash of the base R approach. All right, I'll talk to you in the future.